exponent laws. In this video, we are going to review basic exponent laws that you have seen in previous mathematics studies. So the first thing I want to look at is evaluating powers. So this is something that you've seen in previous math courses. Evaluate means just determine the answer. So you're going to perform the necessary math operations to come up with a solution. So this one here, for example, it says -2 in brackets to the power of 4. So just a quick review with exponents. Remember, this means that you're taking the base, which is -2, and you are multiplying it by itself, and you've got 4 of those. So -2 times -2 times -2 times -2. Okay, so remember, when you have two negatives being multiplied, right, a negative times a negative is a positive. So I've got one positive here, and then I've got a negative times a negative here, which would also give me a positive. And if I've got two positives being multiplied, my answer should be positive. So we know our answer is going to be positive here, but it's a matter of what it is. So if you think 2 times 2 times 2 times 2, your answer is 16. Okay, so that's an evaluated power. So -2 to the power of 4. Now, what I want to do is look at a similar example, except in this case, I do not have brackets. Okay, so I've got -2 to the power of 4 without brackets. Okay, so what this says is I've got a negative sign in front, and then I'm going to take this base of 2 and raise to the power of 4. Now the difference here is that I'm not actually taking the negative and raising that to the power of 4, I'm just taking the 2. So you can kind of see the difference between these two examples. Okay, so I represent that in this way. I keep my negative sign, and then I've got 2 times 2 times 2 times 2. So you can see the difference between these two examples here. Okay, so in the end, if I've got a negative and I'm multiplying by a positive number, my answer should be negative, and I end up with -16. Okay, just a quick little review on evaluating powers. Okay, so the first exponent law I want to look at here is multiplying powers. So the most important part about these exponent laws is that we have to be working with the same base. So if you don't have the same base, these exponent laws do not apply. The first one involves multiplying two powers with the same base. So you can see I've got the same base here and here. And the rule says that I just add my exponents. Okay, so taking a peek at this example here, I've got 2 to the power of 2 times 2 to the power of 6. Now, from the last example we looked at evaluating powers, we know that we can write 2 to the power of 2 as 2 times 2. And we know that we can write 2 to the power of 6 as 6 2's being multiplied, or like this. Now, if we count the number of 2's here, we've got 8 2's, which coincidentally is the same as 6 plus 2. Okay, so we can simplify and write this thing as a single power as 2 to the power of 8. We could just do this by adding 2 and 6. Okay, that's the exponent law here. Now, same situation in part B here, except I don't have the same base with a squared and b do not have the same base, but I can multiply in pairs. A squared and a cubed have the same base, so do b and b to the power of 4. So that's what I'm going to do here. Okay, just applying this exponent law, I'm going to add my two exponents, so I can add 2 and 3, and I can add 1 and 4. Remember, there's a 1 exponent here that we don't write, just for simplicity's sake. But when we simplify, we end up with a to the power of 5 times b to the power of 5. So the second exponent law I want to look at, same situation, we have to be working with the same base. If you don't have the same base, you cannot apply this exponent law. Okay, so this one says if we are dividing powers, we take the exponents and subtract. Okay, so the first example I want to look at, we've got 2 to the power of 5 over 2 to the power of 3. Remember, if it's from evaluating powers, we know that we can write this as 5 2's being multiplied over 3 2's being multiplied, or like this. Okay, and from previous math studies, you might be familiar with the operation that allows us to cancel terms. If I've got one term divided by another term, remember that's just 1. We don't like to write 1 in math. So when we can cancel out a series of 2's until we have no 2's remaining on the bottom. And what we're left with is only 2 2's. Well, 2 times 2 we know is 4, but we also know that we can write that as 2 to the power of 2, which coincidentally, maybe not, is the same as 5 minus 3. Right? So there's your second exponent law. Take your exponents and subtract, and you end up with your simplified power. So same thing in this example, but remember we don't have the same base on top or the bottom, but we do have a pair of same bases. Okay, I'm just going to circle the first one there. Oops, sorry about that. Here we are. I'm going to circle that one there. So we've got a to the power of 3 over a to the power of 2. I've also got a second set of bases that are the same. I've got b squared over b. Okay, so what I can do is apply this rule to each pair of bases that are the same. Okay, so I can subtract my exponents. I'm just going to do this the same way that I did part A. Right, I'm going to cancel my terms. I've got an a on the top, a on the bottom. Same thing. I've got one b on top that I can cancel with a b on the bottom. And what I'm left with is a times b. Okay, so thinking about, sorry, I'm just going to clean that up a bit. Think about our exponent law. We can subtract our exponents. 3 minus 2 is 1a, a to the power of 1, and b squared minus, 2 minus 1 would just be b to the power of 1. All right, the third exponent law, this one's much simpler than the previous ones we've looked at. Really, when you've got a power of a power, so if you've got x to the power of a in brackets, and we're raising that whole thing to the power of b, what we do is we multiply our two exponents. Okay, so just looking at two examples here. This first one, I've got negative 2 to the power of 2, and I'm raising that whole thing to the power of 3. That's what these brackets signify here. Remember, the rule just says take those two exponents and multiply them together. So I'm taking 2 and I'm multiplying by 3 to give me an exponent of 6. Same thing in part B here, but remember with fractions, an exponent on the outside applies to both the top and the bottom. All right, so what I'm going to do is multiply 5 times 2 and 3 times 2 to give me a to the power of 10 over b to the power of 6.